All right, guys, welcome back. This is first session that we're going to do on in this format. So hopefully it goes well. We're going to get used to some of this online content delivery, but we're going to do the best we can. And we're going to break down each module into little chapters for you. And then the idea is that we're going to deliver a chapter and then followed by some code walkthrough. And I think maybe we can organize it in that way, and then it'll be easier to follow for you guys at home than say one hour straight or 1.5 hours straight or something like that. So let's go back to the beginning here, and we're gonna take a step back. Last couple classes we were looking at ES6 and some of that syntax, but we really never got into what full stack development was all about. So I'm going to spend this chapter just going over that and just kind of talk a little bit about full stack web development and why we would want to do that and how it ties into what we're going to be learning. Okay, so this module will be on full stack web development. We are going to actually go on the next slide. So the topics are going to be technology stack versus application stack, and then we're going to talk about what is full stack and then what is MERN Stack. So first we're going to talk about technology stack. So when we're talking about a stack refers to any combination of programming languages, and technology is a combination of software products. So technically there's two types of development stacks. There's a technology stack and an application stack. And you need a bit of experience to understand what that means. Typically, technology stack will be a combination of, say, frameworks, different types of programming language, these types of things. Application stack is a little bit more, it's a little bit more kind of distance from that. It's more, you may be working inside of some type of office or something like that, and they may have some kind of ecosystem, like they may rely on Slack and TeamViewer. I'm just thinking about the current workplace I work at. They have Slack for some chatting. They have a lot of tools actually. And they have Microsoft Teams for some other kind of meetings and collaboration and things like that. And then we have Jira, so it's another application for tracking tracking our tasks, day-to-day tasks. We're in an agile kind of team. And then on top of that, we have a whole bunch of other things. So that's kind of tracking tasks, tracking stories, maybe the QA. The testers may have their own set of suites, applications like for automated testing, or maybe they need to deploy code out for DevOps. So that's what we're talking about, application kind of stack. What might be internal to the team or the company you're working at, what kind of tools they use. But for our intents purposes for this course, we're going to be talking about technology stack. So what a technology stack is, in simple terms, is it's more of a cross-disciplinary term in any software development process. So it's kind of what the team might have, the different disciplines they may use to build software. So you may have some front-end technologies. You may have some front-end developers that are specific to that. They may use their own set of technologies. You may have frameworks that are on the front end. You might also have backend technologies and backend frameworks. And when you get into the database layer, all the development may be different types of technology, right? I mean, the problem with this is if you have a lot of technology in a stack, it can get very convoluted and very confusing when you need to work on a certain project, because you may have say experts in Java, and you may have a Java team that handles, say, web services, and if they only do the Java code, kind of becomes like a little bit of a silo. And maybe you guys are working on, say, C# Microsoft, and the Microsoft guys only work on their code, and the Java guys only work on no code. So you kind of get some boundaries happening, some invisible lines, and sometimes that hurts collaboration. But ideally, you want an ecosystem that everybody can work on, right? And that's kind of what makes a technology stack work, and pros and cons when you're thinking about building software teams, and why it's important. So So this could be some type of example of a technology stack. I picked blockchain because it may be relevant to you. At the top level, they may have all the blockchain um, technologies, Ether, and some of these types of things. To be honest, I'm not a blockchain guy, so I'm not really familiar with all these things. Uh, I'm more experienced in the full stack part of this. So, like for instance, you might have a layer for blockchain that has Ether and Stellar and all these different types of things. And then you may have a backend, which maybe Java, maybe Python, Node.js, which we're going to talk about, which is in our course. You may have a mobile layer, which could be iOS or Android. There's only two there, so there's not too many um, flavors to pick from. Front end, when you get into front end, then you got a lot of different flavors. I'm only showing a little bit to you, but JavaScript, ES6, HTML, CSS3, we know these, right? That's kind of a kind of a kind of a basic kind of web page with some interaction, right? And Bootstrap is a CSS framework that allows some out of the box kind of controls and these kind of things, right? React, we're going to talk about that. So that's a front end framework. There's a whole bunch of other ones that we're not going to touch on right now, but quality. So up there, maybe QA testers and engineers may use some of these tools. I mentioned Jenkins. Jenkins is a build tool, if I'm not mistaken, and we have the database. So I'm just going over some technologies here that you may have heard of Elasticsearch. That's some new technology out there. Oracle is kind of a tried and true database that's been around for 20, 30 years. Redis is caching. It's a caching framework. And then we have environments, right? We have Red Hat Linux, Docker, and some of these kind of things, right? So I kind of spelled environment wrong there, but Docker containers and these kind of things, right? So this is an example of a stack that a company may use. I don't think, you never know, they could use different pieces of it per application, right? Maybe you have some legacy code that uses all a bunch of older technologies in the stack, and then maybe some of the newer, more current stuff they kind of pick and choose some of the newer technologies, and then somewhere in between you have a mixture of old and new. So it's kind of interesting when you go into environment to see as a full stack developer what you're gonna get. To be honest, you may walk in there and it may be dinosaur technology, right, with really old stuff. So, or you may be lucky enough to get into a very modern, very current place that has a lot of fun stuff to work with. It all depends on the luck of the draw, to be honest. So full stack, which is why we're here, right? Full stack development. So when we're talking about full stack developer, so this is kind of an interesting thing, um, because I kind of look at full stack development as you're kind of like a utility player on a say a hockey team or something like that. You're the guy that can do it all. You can play any position. You can be a forward, you can be a goal scorer, you can be a defensive player. Play on the power play as a defenseman, maybe even be a goalie. I don't know. That's a useful player if you could actually do all that. But really, what full stack developer is, it's a skilled developer that comes from all streams, right? To be specific, there's a front end, there's a back end, typically there's front end, back ends, and database, right? And maybe mobile apps. So these are kind of the streams. And we talk about generalization and specification. So if you're a generalist, you are somebody who generally knows a lot of things, uh, maybe very good at different things, maybe stronger at some, but you know a lot, right? And you've been around, maybe you've been to a lot of companies, you picked up a lot of things, as opposed to like a specialist. A specialist would be, as an example in full stack, say you love UI work, and that's your passion, and you're a great JavaScript developer, and you love JavaScript, and you want to work on, say, Angular or React, and that's your focus, and that's what you become. You become an Angular UI developer or a JavaScript developer, and that's all you want to do. That's the only realm you want to touch. You don't want to deal with server, you don't want to deal with database, you don't want to deal with web services or any of those types of things that may be in that stack. Um, there's pros and cons to all those. when we talk about them, but full stack developers are generalists, so they're, like I said, they're jack of all trades, master of none. That's a There's a lot more to that. Like I was trying to get at, like you can't just generalize them as that, but I did. But you may be a master in different areas, and you may have weaknesses in some. But because of how fast technology is and how many different languages there are, it's really, really difficult to become a master at all of the different layers of technologies as possible. You just have to you kind of find your strengths and you kind of play to them. Like for myself, I have experience in 10 years in Microsoft.net, which is another stack, and I tried to forget my past, but you know what? Because of that, I always get calls and job opportunities and all these things for Microsoft.net. So I have to accept the fact that I'm in demand for that. And if I'm lucky enough, uh, I'll get a good project where I'm working in some of that stack with some newer technologies. Like I said, it's the luck of the draw, right? But the good thing is that companies now are rigorously trying to hire full stack developers who can build a complete app from scratch with any discontinuation in the process. So what that means is that a full stack developer is very useful nowadays because you can throw him in there and he can actually contribute at all levels, right? He can go wherever the project needs him to go. He may be stronger in certain, say in UI, but at the same time you can pull that guy back and you can put him on the database. Like I said, the hockey analogy, you could use that player in different types of situations when needed, and that's a useful developer employee to have. So companies are now, some of them are just saying we only hire full stack developers. I haven't been to a place like that. There's always a mix, but there's a new trend now, and that's what they're going for. So here's a kind of a big picture of what I was talking about. So full stack development is kind of over encompassing all of this. So you may have front end dev, backend development, the technologies there, database, and DevOps. So DevOps is, if you don't know, it's the development or deployment operations, right? So these guys deal with deployments of builds and things like that. I'll get into that in a second. Then there's mobile app development. So it's a very broad scope. And like I said before, it's very hard to be an expert in any one of these layers. If you can go across all of those, you're great. Myself, when I'm looking at that, I'm very strong in 3 of the 5, uh, with with the exception being I'm getting a bit better at mobile, but DevOps I'm not good at. So not that I can't do it, it's just I don't have much experience, and I don't really, to be honest, have that interest in that. But some people, they really love that, and that's what they're all about. So front end development, again, it's UI, so it's maybe CSS, JavaScript, SPA. So SPA is single page application, and then we're talking about all the JavaScript frameworks, user interface interactions that the user will see at the presentation level. Backend development. So backend development would be something server side. So Python, Node.js, Microsoft.net, right? These kind of things. And backend development typically kind of puts a lot of this, bridges the gap between front end development and database. And a lot more than that, there may be web services going on, there may be caching going on, there may be a whole bunch of business logic going on in that layer. Database, of course, deals with data, storing data, big data, retrieving it. CRUD operations are create, update, delete, all these types of things. Performance is a lot more than that. I'm just kind of shallowly going over that. DevOps, like I said, would be automated deployments, builds. AWS would be cloud services. CI means continuous integration. CD means continuous deployments. So if you recall, I might have talked about in an agile environment, they have such things as 2-week sprints, right? So every 2 weeks they're trying to deliver some type of feature. Every 2 weeks they're integrating the code. They're constantly deploying, right? Maybe they have to different environments. They have code going up every two days, depending on their whole schedule, and then they may kick off automated tests. What they're trying to do is they're trying to get feedback right away so that they can minimize problems and minimize errors and all of these things. Where opposed to, say, in a waterfall scenario, you're working on some code or project and there's many projects going on for maybe half a year, and then what happens is at the end of that half a year, all hell breaks loose and people are running around with their heads, cut off like chickens, and it's just a very stressful time, right? So DevOps and these kind of things, I mean, they're responsible for all these tools. What I talked about, agile versus waterfall, that's more of a project management kind of uh, thing that is over top of all of this, right? So, but DevOps would be very important in both of them. Specifically, more important, I would say, in agile kind of development because they're needed regularly for continuous builds, continuous deployments, constant feedback. So that's what they do. Mobile app development, of course, hybrid apps, iOS, Android. So just another UI. I mean, you could consider that front end, but when you're getting natively, it's a whole other ballgame. So this could be the full stack, right? And just me talking here about it, um, you can tell like there's a lot to each layer, and where you spend your time, how you spend your time, where your experience takes you in full stack development, kind of will kind of mold you into a full stack developer with specific strengths and weaknesses, right? So anyhow, there's a lot to learn there. And some people just say, you know what, I'm just going to be a database guy, and there's nothing wrong with that, and that's perfectly fine. I know a friend who's an Oracle developer, and he's a performance specialist, and he does it very well for himself, and that's all he really likes. He likes writing queries and SQL and all of that, so more power to you, right? So full stack development, now we're looking really at like some technologies here. So Node.js, which we're going to really talk about, Scala, Python, Bootstrap, PHP, Ruby, Ruby on Rails, more server side. PHP is more server side. Bootstrap is UI. Python's more server side. jQuery now we're talking about. Now we're going over this kind of arc here. We're talking about front end technologies. VBScript, bit older. React.js, which we're going to do in this course. AngularJS, similar to React, another framework. JavaScript, which we've done. ES6, which allows us to have all these frameworks because of its dynamic and openness. And then we have the presentation kind of markup, HTML and CSS. So the benefits of the full stack developer, like I already talked about, there's a lot of benefits, right? Knowledge of both backend and front end technologies. I can tell you are always learning when you're doing full stack development, always. You can easily take charge of the project responsibility, meaning you can jump in anywhere and you have a lot of say because you're touching all pieces of it. Cost effective to a company because they want to hire people that are versatile, right? They don't want to hire maybe somebody who is, not to say they don't, sometimes they do go for specialists, but you don't want a team of specialists, right? Because then the lines can be divided, right? You only touch your piece again, and then you only touch the back end and all these things, right? Full stack development is one of the most demanded jobs in the past years, which I'm pleasantly surprised. I started researching myself just while doing this, and yeah, there's a lot of opportunities out there. I already knew that, but it's actually grown a lot in the last few years. So, but interestingly enough, it wasn't always the case. I actually was remember this. I wasn't around for that time, but in the 70s, programming and development wasn't multi-layered like this, right? You basically were working on a system, and the system really didn't have a UI, and it was assembly or it was a COBOL or something like that. Maybe you had a banking application you had to do, and back then, it was just a terminal, and it was basically just the old school green kind of screen, and you were basically had a simple menu, but it was doing a lot in the back end, right? And you were just working with the system and trying to make it run fast. And some of that old tech is still around, and we layer on top of it. Talking to a friend whose relative was a COBOL developer, and he was still, he just retired, but he was working all the way up until he was, I don't know, 70, and he was doing contracts, and he was working on Interact, and he told me that a lot of the banks and Interact is all built on COBOL still, and the reason why they don't change it is because it's lightning fast. It might be a million lines of code, but it still works really well. And like I said, at that layer, at that time, they didn't have to worry about all this type of full stack. It was basically you were just a COBOL developer or assembly developer. All right, so this is what I was trying to talk about. I looked at just today. So tech roles ranked by employer demand. Number of postings per million, job postings. So if that's right, that's quite a lot, if I'm not mistaken, per million job postings. So is that saying? In a million jobs, we are almost getting at, say, what, 850,000 tied front-end developer with engineering manager. So you know what? Front-end developer, that spike is because of the last few years, like React and Angular really has taken off, to be honest. React is very much in demand. I wasn't fully on the React boat, but now I am. I was coming from the Angular camp. DevOps, that's surprising to me, to be honest, but you know what? It has, builds are important now, and continuous code integration is important. Full stack is a fourth. And you know what? That is for being a utility generalist, that's pretty strong. You know that? If you're a full stack developer that knows something React and strong front end technologies, you got a really good job opportunities out there. UX designer, fifth QA engineer, mobile developer, data scientist, backend developer, so on and so forth. So I was interested in the top one there, engineering manager. Somebody said to me one time, it's like, if you can't really program and you're really good at talking, well, we got a job for you. It's called manager. I don't know. I didn't say that, but he told me. It depends. I've seen some technical managers, but some I've seen, it definitely could be true to that statement. Anyways, moving on. I won't touch that. The MERN Stack. So the MERN Stack is the stack we're going to be looking at, and what that is it comprises the following technologies: MongoDB for database, Express is that layer in between, that API kind of layer that's gonna bridge the gap between database server and expose that to the world. So, and then React will be the UI. React will be what is consuming that, and Node.js is the server. So really, the flow would be UI React through Express through Node down to MongoDB, and then back up from MongoDB to Node, Express, and React. If you were looking at a full stack and the direction it would go. So the benefits of the MERN stack. So the advantages for developers using the MERN stack is that every line of code is written in JavaScript. And what I talked about before is when you have lines drawn in the sand with boundaries per technology. Like you have Java guys over there, your .NET guys over there, and they're not going to talk, and maybe you have the database guys over there, and now you got a problem, right? Now you have to go to their managers and whatnot to get them to do some work, and it's can be very political. The idea is that when everybody is doing the same language and everybody can write JavaScript code, everybody can have the same conversation. And not to say those lines aren't there, but if I know JavaScript and I'm a full stack developer, I can certainly go and I can work on the database because it's a JSON object and it's written in JavaScript. So that's the idea and the benefit of having a stack like this. So the programming language is used everywhere in all layers. So that's basically what we're trying to say is one language across all the tiers. There's no need for context switching, and everybody speaks the same language. So the whole point to all of this, and what I'm getting at is when we're going to be talking about MERN stack, you just have to know that JavaScript, like we talked about ES6, like this is very important. And for all layers, we're going to be using the same technologies, and basically bridging the gap between all those type of layers, and basically we can speak the same language from front to back. So that's why it was very important that we were doing a lot of JavaScript. All right, so the next module we're going to talk about NPM.